In this video, we're going to talk about what happens with these photons, these X-ray photons that was created by the Bremsen the characteristic. What we're going to learn is these photons are now going to travel down the tube and they're going to interact with matter or the human body. We're going to learn about 5 of these interactions. The diagnostic ones are going to be the photoelectric, the Compton, and the coherent scatter. And then the therapeutic for treatment is the pair production and photodisintegration. So let's take a look at photoelectric effect. What happens with the photoelectric effect is you're going to have an X-ray photon that's going to be traveling, and it's going to go straight to your inner circle, which is K. What happens is once it gets here, it gets absorbed. And it also ejects this electron out. This ejected electron is called a photoelectron. And when it gets ejected, now what's going to happen is the L shell now is going to fill in. And it's going to fill in. Now remember, the ability to eject an electron is known as ionization. And that's what's occurring here, because this K electron is getting ejected out. So this process is called ionization. And this is called the photoelectron. This is the photoelectric effect, and it's when the X-ray photon is absorbed. So that's why it matters in regards to the anatomic tissue. It all depends on the energy of the X-ray photon and the atomic number of the anatomic tissue. This photon has to be equal to this K shell. So that's what happens with the photoelectric effect. This is total absorption, creates a photoelectron, ejects this K shell out. The ejection is called ionization. The next effect is called the Compton effect. Again, you have an X-ray photon that is only going to interact with the outer. Okay, so the X-ray photon comes, then ejects this electron out. What happens is this incoming photon loses energy and changes direction. This change in direction causes it to scatter. So now we have scattering that occurs. And remember, this scattered photon is going to go hit the IR. And as we know, scatter that hits the IR just creates fog. It's unwanted, so that's why it creates fog. So scatter hits the IR, it creates fog. This is the Compton effect. The outer shell gets kicked out, which creates scatter, to hit the IR, which creates fog. The next one is called coherent scatter. Now, it only occurs with low energy X-ray photons. Low energy ray photons won't have a high frequency. And it really doesn't do anything except cause the electron to excite or vibrate. There is no ionization with coherent scattering because no electrons is going to get ejected out in coherent scatter. Remember, coherent scattering is it's a low X-ray, low. See how low it is? And it just causes to excite and vibrate. Now we're going to talk about the therapeutic interactions. The first one is pair production. So what happens with pair production is you have a high energy you're going to have a high energy photon, okay, at least 1.02. The photon goes into the nucleus, and that's where it loses all its energy. And this is where the pair creates a pair. One pair coming here and another pair coming here. It creates the positron and negatron. So it creates a pair, positron, negatron. Remember, it's a high X-ray photon, 1.02 MeV. It goes straight to the nucleus, loses its energy, and creates a pair. Thus the name pair production. The next therapeutic one is photodisintegration. Excuse my misspelling. Again, this one is even higher than the pair. Of greater than 10. So the X-ray photon comes, hits the nucleus, and what it creates is a nuclear fragment. And that is what photodisintegration does. So now we learned about the interaction with matter, which is photoelectric effect, Compton effect, photoelectric effect, Compton effect, coherent scattering. And then the other two for therapeutic is pair production and photodisintegration. Remember, all these occur in the patient because it interacts with matter.